Good morning, my dear thinkers. This is your mentor, Srinivas, trying to help you to make this line following robot. So we have here a chassis, okay, to make this. And we have some geared motors, okay, yes. And we have a battery compartment, and we have some wheels also, and electrolytic capacitors. They are called electrolytic capacitors. Okay, they will have the polarity plus minus, and I will see and tell you what is the value of these electrolytic capacitors. Okay, microfarads. This is 10 microfarads by 40 volts. Very important. You need to know what is a microfarad and what is the voltage. I'll tell you all about this later. And we have few resistors here. Okay, we'll know what is the value of these resistors. So one type of resistor, another type of resistor. They are metal film resistors. Okay, very accurate. The value of the resistance is very accurate. Okay, the tolerance is very less, maybe 1%. Okay, maybe less than that. So metal film resistors. And we have transistors. So these transistors will have 3 leads: base, collector, emitter. And we have here light depending resistors. The value of the resistance of this LDR based on the incident light falling on these LDRs. So you can measure and see them. In full light, what is the resistance between these 2 leads? And in the night time, how high the resistance is going. All these things you can check it out. And we also have few LEDs, 2 of them white, 2 of them red. Okay, and we do have one integrated circuit, 8-pin integrated circuit. To solder this integrated circuit, we can use this IC base. And we have a switch, push to on switch, and 2 variable resistors to adjust the sensitivity of this project and all, okay, at the sensing point. So let's see how I can help you solder these components on this board. This is solder side and this is component side. So we have to keep the components and to this component side, and then on the solder side we will solder them. Okay, so we have a special stand to hold the circuit board so that I can show you the perfect. I'll ask my assistant to bring it that solder stand so that is called, we can say, project holder. We can keep this circuit board and tighten that, and then we can do better. Okay, so yeah, I asked Sirisha to go and get it. So meanwhile I can show you how we can keep the board ready. Okay, very interesting. Do it yourself. So you can get these kits and then do this tinkering, right? Okay, good. So let's start soldering. And for soldering, my dear students, we need to use this solder wire. Okay, so how do we do the solder? Nicely using this soldering iron. Let me check whether it is melting or not. Let me switch on the soldering iron, and then after a few minutes it will be ready for soldering. Okay, that's nice. See, space, right from, once again, I wanted to make you understand. This is the board for this project, line following robot, and you will be putting the components and then you will be soldering on this side. Okay, this is solder side, this is component side. See, all these LEDs and then capacitors and few resistors here. Okay, and then 2 transistors. Yes, these 2 transistors. Okay, all these things will be soldering. Once a minute. Okay, so my dear students, my dear thinkers, now we always need to follow some rule. The rule is we have to solder the low height components. So I have checked up all these components. The most low height components are these resistors. So in our this particular project, there are 4 different kind of resistors we will be using here. So we need to know which are the values there, because here they are using 1 kilo ohm, 1 kilo ohm and 51 ohms. Okay, and here is 33k or 3.3k. We need to know this. Okay, likewise there are different resistors. This is variable resistance. So we need to know what all the resistance we have here and know the values. So to know the values, you need to know the color code. Okay, so as you have not practiced as of now the color code, that's why I will use my digital multimeter. Okay, so this digital multimeter will help you right now for time being. Okay, so I wanted to measure, okay, the value of resistors. Okay, now let me put it into, because this has got lot of things. So to measure the resistors, ohms, so I'm going to put here 2000, because some of the resistors in the board, they have mentioned, 1 kilo ohm. So I just wanted to take out which are the 1 kilo ohms. Okay, so if I put it in 200 ohms, then my meter won't be able to read that. That's why I wanted to first find out 1 kilo ohms, which is, here it is 2000 ohms. It can measure up to 2000. So this is appropriate for this. So let me know which is the 1 kilo ohm resistor. Let me check. It looks like, because brown, black, red. Let me see. You can see from here also. See what is the value it is showing? Very less. It is showing very less. So why it is showing less? Only just 10 ohms. This is only just 10 ohms. Okay, so 10 ohms. And here what is the value of this resistor? Okay, you see, this is 51 ohms. Yeah, we need them. 51 ohms also we need them. And 10 ohms and 51 ohms. This is showing more. So, wow, it is 3.3k. It is 3.3k. Now, one more. Okay. If you touch 2, then the 2 resistors will be in parallel. Only we need to touch. This is 1k. 996 is almost 1k. So, this is 1k. So, we have 10 ohms, we have 51 ohms, we have 1 ohm, 1 kilo ohm, and we have 3.3. So, I kept them in line for you. Okay. Now, I'm going to solder them. So, to solder them, I have a project holder here. I can hold, and keep this board here, and I can open it, and I can put it, and I can tighten. You see? Then, this project holder, the circuit board holder, will help me so that I don't need anyone for. Now, let me, what I will do is, I'll show you by little zooming, okay? So that you will know better where I'm soldering, what I'm soldering, all these things you will know clearly, okay? So, let me put the components and then start soldering. As I rightly said, I have 2 10 ohms and 4 of 51 ohms and 1 kilo ohm 2 ones, and this is 3k3. So here I just need to know what to be put here. Okay, see what they are asking us to do. See, 1 kilo ohm, 1 kilo ohm. Okay, so 2 of them. Okay, then 3k3. Okay, 1 kilo ohm. I'm taking 1 kilo ohm. And before I solder this 1 kilo ohm, I just want to make sure my resistors are clean. Otherwise, they won't properly catch the solder. Okay. So I made it very clean, this 1 kilo ohm. I'm going to put it into the slot given for the 1 kilo ohm. You see, I'm putting the 1 kilo ohm resistor for the slot given. So as it shouldn't come out, so I'm taking, some little angle so that it won't fall down. Okay. Similarly, I am taking one more 1 kilo ohm, and then once again I'll just clean it like this, okay, so that I can solder these resistors very nicely. So I'm putting this 1 kilo ohm, and I'm done by putting these two 1 kilo ohms nicely. So now you to tell me whether I solder them first and then, you see, I'm going to solder them so that you can see how I'm going to solder them. Okay, so I have a lot of solder wire here, but I don't need that much. Why unnecessarily carrying so much of solder wire here in my hand? So I have removed little bit and I can keep it like this. Okay, so I just made little solder wire handy for me. Okay, then you see, I can solder. Before I solder, I'll just check whether my solder, yeah, very nice. Now I'm going to solder. Okay, so while soldering also, I just need to heat the pad and then you see, apply little solder wire there very nicely, very cleanly with very little solder wire. I can nicely solder all the 1 kilo ohm, both the 1 kilo ohm were properly soldered. Okay. Okay, yes. Now what I can do is, I'll take out my lead cutter. Okay. I can remove the extra leads and I'll keep the leads because they are coppers. So we can recycle them, right? So I have removed the extra ones. Now I need to know what to be put later. Now my 1Ks are done in the place. Now I can go for 3K3. I have 3K3 here. So once again, the same process, okay. I need to, because of course, okay, little cleaning, okay, and then hold the resistor properly and make sure you will insert them nicely in the given slot. Okay, that's it. And again, make sure that you will bend them to this direction. Okay, in similar, these 3K3s are going inside. Both of them. I have sent both 3K3s, 3.3 kilo ohms. Both of them are done inside. Okay. Now once again, I am making use of the help from my project holder, the PCB circuit holder, whatever. And then I am soldering that 3K3 on the both sides equally with the most minimum solder wire used, because I've used this heating first, then when the pad is heated, then I have applied little solder wire there. Okay, so 45 degrees this one, 45 degrees this one, nicely the both properly. Okay, now I am going to cut and keep the extra leads of the resistors, 3 kilo ohms, 3.3 kilo ohms. Okay, now I need to know what else to be put. Okay, this 51 ohms, 51, oh, 451 ohms I have to put. Okay, I'll do that, no problem. Okay, see, I have 4 of them, so I can put them, okay, into this slots. 51 ohms. You need to know the color codes properly so that you will understand very easily. Okay, what is 51, what is 470 ohms, what is 390 ohms, what is 313 ohms. So suppose say 1 kilo ohm means brown, black, red. Okay, likewise, suppose if it is brown, black, brown, it is 100 ohms. If it is brown, black, orange, it is 10 kilo ohms. If it is brown, black, yellow, it is 100 kilo ohms. So you need to ask me, so how the value is changing? Brown, black is common, but however, the last number, the value of the entire resistance is changing from 100 ohms to 1 kilo ohm, 1 kilo ohm to 10 kilo ohm, and 10 kilo ohm to 100 kilo ohm, 100 kilo ohm to likewise how the value is changing with last color change. Okay, so you need to follow that. Now I am going to solder this 51 ohm resistor. So once I solder this particular 51 ohm resistor, we can use, because whatever fume you are getting over here, so you can always use extinguisher here nearby. If you have one, then that will automatically take that, all the fumes away from you. But it's a small little project, matter of 10-15 minutes. I'm just fastly doing it because of this 1st of January 2024. I want to give you little mentoring. Just tinkering and mentoring must go together. That's why I'm tinkering now. While I'm doing tinkering, I'm trying to do the mentoring required for this tinkering. You understand, my dear friends? See, now I'm lifting them and I'm trying to solder these fellows also nicely. Okay. So, whenever I solder, what I'm trying to do is, I'm cutting off and clearing the place ready for the next solder joint to be soldered. Okay. That's how we need to clear off as soon as we have done required soldering. Okay, that's it. How nicely you are soldering. Okay, see, with the minimum solder wire, you have soldered all of them. So, now 2 more resistors are left, 10 ohm fellows. We need to understand where to use this 10 ohm resistor. See, 10 ohm resistors are here. So, we'll use this 10 ohm resistors there. So, now the question to all of you is, I'm waiting for you guys to ask me, sir, you are only putting the values of the resistors as they have mentioned there. But how do we know, like, why we need to put 10 ohms here and 51 ohms there? And who told you, like, why they have printed the values there? How do they know? These are the questions you must ask me. Okay, I will tell you later. In another one mentoring session, I will tell you all that. Okay, right now tinkering is going on. So let us do tinkering now. According to the given instructions, once we complete this tinkering, once your project starts working, then probably this kind of questions like, why only 10 ohms? Why not 100 ohms here? Likewise, all that questions we can discuss. That and all design aspects of these projects. We will do that. We will discuss about that. That is more important than just soldering them. Okay, we need to have a thought. Why do we need to use that value only? Okay, now let's go for, we have done good soldering for the resistors. Resistors are done. Now let us go for the next high components. Here what I have is 2 capacitors. They are little taller. So I think transistors and this particular light depending resistors. But so we need to go for soldering this one, the IC base. But for soldering IC base, what happened? I just found one of its lead. See, it's not straight, so we need to make straight, otherwise how they will go in the slot. So I'm using my tweezer, okay, forceps, okay, then it will have a slot like this. You see, we have to follow this slot. Here is a slot. So pin number 1 anti-clockwise, 1, 4, 5, 8. So here is a slot. From here we have to count down. So here is a slot given. To this IC, slot is given here. So we have to match slot to slot. Okay, then only we can solder. Otherwise, while putting the particular IC into that, you will put a wrong direction. So what we need to do? We have nicely inserted this particular IC's base inside. The reason why we are using IC base, very important. We need to discuss about it. You ask me, okay, why we are using IC base. Now my problem is, my IC base shouldn't go down. That's why I just used some little technique, and you might have observed the little technique. Now the next little technique, what I'm trying to do is, I'm soldering one particular pin of IC base, and then I'm confirming it that is properly done. And once I confirm, I'll go diagonal, okay, to check Whether that is proper? Yeah, that is also proper. Now I can close my eyes and do solder because the IC base is not going to go down. Okay. Nicely I can solder all the pins of my IC base easily with very little solder wire. If you use more solder wire, then what happens? They all will get short circuited. So if you use a magnifying glass and see, there shouldn't be any short circuit between each point to point. Okay. So this is how I have done it very nicely. Now let's go for some other component. See here there are two resistors. Transistors. So I am using two transistors. But I have to go, this is also very important, use this tweezer to keep them this little away because the distance of the base emitter collector is given, you see. And the most important point, my dear friends, you cannot push totally down to the board level because the distance of these pads are little larger than the distance of the transistor leads. So you have to keep them there only. Otherwise they'll get broke. They'll be separated from the transistor body. So, and another most important point, what I have seen here, you see in the board they are asking in the component layout. This is called a component layout. In the component layout, they have clearly mentioned that our transistor must face, because this is a face, okay, this is very important. If you put reverse, then the collector and emitter, the base in the center is going to remain same, but the collector and emitter will be reversed. That's why it is very important, okay, for you to follow the given instructions. So, I'm going to insert according to the given picture, the drawing onto this. And then again, as you know that I'll turn onto that side and just solder one terminal. The most important point you all have to know, once you solder one particular base or emitter or collector, never do solder at the same time again because you know that the heat and transistors are semiconductors and the heat must go away. Because the heat will go into the junction, no? That's why what I'm doing is I'm doing some soldering on some other junction and again coming back to whatever, you know, this is how by the time you solder somewhere and come back, by the time they all will be done, okay? Now I'm going to cut the extra leads. But again cutting, this is very important instruction. I need safety. So you all have to use safety glasses. Otherwise what happens while cutting this particular leads, the transistor leads, if you press a little faster, this lead cutter, then they will jump and hit the eyeball. So that's where what we need to do is make sure you will use this safety glasses. Okay, then nothing will happen. Even if they come up, and now I am trying to arrest their physical, movement so that, I can keep them at one place safely. I can dispose them safely. That's why I am holding with my tweezer. So I am done with my transistors also. Now let me go back and see what are the things. Oh, two capacitors to be soldered. And there is a plus minus, the plus and minus written. So here, this is plus, the taller one, and then the other one is negative. This is electrolytic capacitor. We have to definitely follow the plus minus, otherwise it will be trouble. So I am putting the plus to plus and the minus to minus. Okay, done. I am happy. And in similar, the same thing, the same way I am also doing here. Okay, yeah, I am done in the both way and I pressed it inside. Now again, I will turn back so that on solder side, I will be soldering them so that they will be permanently connected to my required circuit drawing. Okay, why I am soldering? Soldering is to connect to the required, circuitry. I just want to close the circuit as per the design. So the design circuit is basically a schematic drawing, and whatever way we want, so we design the circuit. So based on the design, so what we'll do is we'll develop required artwork. So based on the artwork, these PCB circuit boards were made. So later, you can keep your components. You see how nicely they went inside. Now later you will be putting LEDs. For LEDs also you have color, anode cathodes, positive negative kind. Anode is the taller one and the shorter one is the cathode. Here they have mentioned symbol of the LED. The line is cathode, the triangle portion is anode. So this has to go this way. Okay, similarly this way. So this is very important. You have to follow that. Okay. Now once again I'll solder this. Happy? So very importantly you need to follow this particular instructions, and then then give a little angle to that so that they don't go down. And now what I'm doing, I'm just soldering one point of it. So what happens, I can lift and I can push from down, and once that is done I can solder the second one. Okay, now I can push and see whether, yeah, you see so much. Now that I'm going to do it for the second ones, so that totally they are connected and the required physical strength also is given to that cathodes. So I'm doing for cathodes. Okay, done. I'm done for anodes and cathodes. Properly they went inside, okay, nicely, and the LED is sitting on the board. So this is very important. You need to know all that, right? You see now, you know that. I don't have to tell this. You have to have the safety glass, and then you have to use your tweezer to hold it. Okay, and then cut the extra part. And you should not keep it anywhere here. You have to keep it on some other side. Okay, and similar to that, you can cut this portion also. Okay, and you see, this is how you are separated. So you are done with your this LEDs also. Here, two more components we have to use, these LEDs and LDRs, but we have to solder some more things here. Okay, let us complete this one or that one. Let me see. I have to complete this one. So once I complete this one, then see, I'm going to open it and see what to be put, where to be put. See, there is LED 1, LED 2, and plus and plus. That means anodes. So anodes are down here. Okay, so anodes the taller ones. So the taller ones must go this side. Okay, and now the question, actually I need to keep this LEDs like something like this and solder them. Okay, so the most important point for me, unlike earlier, I'm not going to solder these components on the component side. I'm going to solder these fellows on the solder side. So that will help me for my project. You will understand that while I'm demonstrating the working of this project. Okay, till then just go through this. Okay, till then just go through this. You see, now I'm going to put this component here and then solder it there. So I will be doing it. So no one else is there for me here. So now I have to manage myself. So I have to hold this and then solder this component because I want this LED to be there. And like this, and then slowly, nicely. Okay, okay, it went so much inside, I had to bring it up because it went so much inside. Okay, I'm trying to pull it up. Okay, now little more I think so. Let me check that whether how much. Yeah, I have a lot much more. So I have to keep it down. So I have to push it inside little more. Okay, I have lifted maximum. You see? Yeah, most of that it went inside. Now I think that is sufficient for me. Now I can solder the other side. I mean the cathode. Okay. So now I am soldering the cathode also. Once I solder the cathode properly, after 1 or 2 seconds more, okay, and in similar to that, I can also solder this fellow also, this LED. Okay, this is very interesting. Okay, I'll just solder it I know I will give, and later again I'll make it straight. Okay, just after another, see, now I'm going to make it straight. So in the first, I have to make sure that goes inside and check here it has come. So now I'm going to solder the cathode. Okay, so properly. This is very important. So I have properly soldered the cathode, and also I want to check the first anode also properly done, and here also the anode properly. Yeah, I given the required physical strength with a little more solder wire there. Okay, now these LEDs were soldered properly. Now let me solder my LDRs. Okay, I have LDRs. So I had to use these LDRs. See, they have given very, the leads are real good. I mean, very much lengthy. So I can make use whatever way I want. Okay. See, now you see, I'm just tightening them to check whether they are properly made, manufactured properly or not, so that if there is any problem, that they will come out. Okay, now you see, I made them properly. Now, actually, I can use a small sleeve also so that they don't touch together. But, offering problem is, okay, good. Let us see without insulating them, how good we can solder these LDRs. As, this in similar, the same way we have soldered in the similar, in the same height. We need to solder the same height. This is very interesting. So what I am trying to do, I am going to give very little lead to one of its lead. Here, see what happened. The heat went inside, okay, and it touched my finger also. So this is how we have to be very careful working with such kind of heat and that. Okay, no problem. From the LDR, the heat is going very fast. So we can do some other techniques. What best, instead, without touching, how can I do that? Is a good idea. I can use this scissor. Why I am unnecessarily using my hand to hold it? You understand? So I just need to check the height. Okay, and now I need to take little solder wire and do the soldering here. And in between, I just found here my project holder, that nut has come out. Good, I can tighten it again. Okay, good. Now I can solder that LED properly, LDR, with the height, proper height. Okay, now I can put some lead there. Okay, I kept some solder wire there. Now it won't go inside. Now height is same, and I can do the other one very perfectly here. So here, see how I am trying to do this. Okay, see, I am trying to do this. Yeah, nicely I did it. And then, since similar, I am going to do it for the other point also. Okay, for the other point also. See here, same height should be maintained well. Okay, and then you just solder one point. Okay, here one point, and leave it, and you check whether the height is proper or not. Yeah, proper. And then once the height is proper, both are at the same height, then what we can do is, we can solder the other also. Okay, so this is how on the component side also I am trying to solder. Okay, nicely. Yes, yeah, you see, very nicely I have soldered. And again cross checking these fellows. Okay, good. And I am checking that side also. Good. And I am checking this side also. Good. So that no loose connection, I think. Yeah, done properly. You can see all that same heights. Okay, and Good. So we have done a good job. And I don't think we need to cut anymore here for the LEDs. But for LDRs, yes, of course, they have come out. So we need to cut that. Okay, so we'll go for this extra. We'll remove them. We can remove them later also. Let us see if we need to adjust them there and here. Then we can adjust it. Now let's go for these potentiometers. Okay, potentiometers and the variable resistance. Okay, and then what else? A switch. Okay, switch is also equally important. So I'm just tightening my project holder to me in sides. Now here we need to know how these fellows have to go. Okay, this is very important. Okay, we have to go through the given indications where this potentiometers to be put. You cannot put as you like, you have to follow the rules there. Now the switch also. In switch also we have to follow. Okay. Now we need to solder all of this. Then our soldering part is done. So let us solder these three components. Okay, let us solder these three components. But once again, the rule is same. The rule is just solder one point and make sure, it's only just one point. You see the switch went down. Okay, now I have to keep it again and make sure the switch will go in its way. Okay, see, it has to go. You see? Now, because I already soldered, it is not allowing the pin to go in. No problem, I will do this way. Okay, nicely I sent inside and I am cross checking the switch will go and sit on the board or not. Okay, yeah, it properly went inside. Okay, now what you need to do, you can check these particular points. Now I am going to solder the rest of the points of the switch. Here, this side, I don't think they are in the circuit because there is no track connected to these particular points. Okay, but still that will help you if you solder them. That will help you for better connectivity. I mean, physically the switch is properly mounted. So here only these two are the main points for the entire circuit. Okay, so we have done that, but now we need to solder these presets, the variable resistors. Okay, so now I am going to solder these variable resistors to adjust the sensitivity of the signal, whatever. Okay, for our project. Our project is what? Line following robot. So how it follows the line? So the left, whenever it is going out of the line, how it will understand? How it will come back to the line? That and all we will discuss. I will tell you, I will make you understand once I complete the fabrication. I think mostly I have done the fabrication now, just because, if I need to adjust the lengths and all. So most of the part, of this project, I think I'm done soldering part. Now I'm going to insert the integrated IC. Okay, you see, IC will also have the notch. So we have to match the notch to notch. Okay, then we have to push it. And then this IC pins will get connected to the IC base. IC base anyway it is connected here. No short circuit, nothing. They are all properly connected. Okay, so this is how we need to tinker. This is called tinkering. Okay, so once we complete the tinkering, then we will see what best, how good. Here the motor 1, motor 2, and here is the battery connection. So 3 more things are left. So for the motor, yes, this is the battery power. Motors, we need to use wires like they have given this wire and one more wire. Okay, so for the motors, or otherwise I have to take out from my inventory and use them, because only one piece I see, maybe another black one I found. Oh, it is, they have given us here only. So, see, this is how we need to open them. And then use this wire stripper and then remove the insulation on this and then tin it and solder it, okay? This is how we can do tin it and soldering it onto the board and to the motor as well, okay? So, we have done complete our work, and then after that finally we'll remove the wrapper and then we'll use the battery compartment here. And also we'll remove these fellows and we'll stick the gear motors here. Okay, then the wheels will be tightened, the given wheels, okay? So we'll use the screws and tighten, and we'll use the third wheel, a supporting one, this one, okay? That's how it's going to. Then we'll draw a line, and according to the line width, these two sensors will control. If it is going out of the line, and the signal will be given, and it will be adjusting the motor to the other direction. Likewise, it will go, without going out of the line this direction or that direction, the same line direction, the straight line, it will go. So that and all we will see once we complete all the mechanical fabrication. Okay, now the mechanical fabrication is left, and also connecting the motors. Connecting the motors, there are little connections are there. So I suggest all of you guys to clean them once, okay, because they might have oxidized. So what I suggest is, so you always clean these geared motors. So why we are using geared motor? Another question. My dear tinkers, you need to answer me this. Okay, now I can lift these connections a little bit like this. Then I can tin these connections, so that next time when I am using wires on that will be easy for me. So what I am trying to do is, you see, I am trying to put some solder wire on it. This process is called tinning. So we are making our motors ready to solder with wires. Or otherwise, if you put the wires there and if you are trying to solder them, then they won't be properly soldered. So it is better, I suggest, you always tin these motors first and keep them ready, okay? So that you can easily solder the wires. That's how the wires can be soldered on the circuit board easily. Okay, so later they don't fail. Okay, they don't come loose, no loose connections. The perfect wires will be there. So this is how I just prepared these motors, tinned, ready. Okay. Okay. Now I think I can prepare cables and tin them, even these fellows. Okay. Then once I just add some solder wire to this cables like a tinning, I told you, then what happens? They are ready to get soldered on these pins. Now the another question what we have is where to solder positive and negative. Nothing to worry. If they are not working in a direction, then you can reverse them. Okay, doesn't matter. So I hope you understood. Now let me complete the little mechanical work, fixing this one and removing the tape and putting onto this and connecting the wires and all the stuff. And then when I press this button, when the energy go from this battery compartment to the circuit board, and when it is following the line, at the time I'll come back and explain you about the functionality of this project. Till then, bye bye. Take care. Happy tinkering. I wish you all a happy new year, tinkering new year, innovative new year on this 1st January 2024. Okay, my dear tinkers. Yes, as I promised you an hour ago that I'll complete the mechanical work and all after my lunch time. Then finally, after my lunch, I've done the mechanical work. Okay. See, finally the motors, the gate motors are sticked onto the PCB board, and also the sensors, and everything is the front wheel. It's not a wheel basically, but to slide. Okay. And also I stick the battery compartment And you can see everything is ready now. And also, most interestingly, I have connected, the wires, you see, the motor wires. And I use the glue also on the motor so that even if you try to pull out easily, the wires won't come out from that motor. That and also you can see, I use the glue gun. So, what else? Now our line following robot is ready for testing. Let's see what happens. So, let me switch on. Okay, what happens you see. Oh my God, it is going there and here. Okay, it is going there and here. Oh, it is going. It is controlless. Okay, it is controlless. There is something happening. I could not control it. Okay, see, we need to make it control. Okay, by doing what? Okay, we need to control it. It is not at all controllable now. It is going all across the places. Okay, it is going everywhere, right? You see, it is going everywhere, ever. It is trying it level best to. My God, how do I stop it now? Okay, see, now what you understand from it is, now it is controlless. We need to make it control because this is basically made, for line following robot. So this is the main important sensors. The sensor in the sense, one is the light source from here and other is the receiving, the LDR. Okay, if the whatever light ray comes from out of this LED, if it gets reflected back into the LDR, and the resistance of that LDR will change. So based on that, we have designed some, circuitry. So the error correction amplifier, okay, that and all I'll explain in next upcoming sessions. So the error correction amplifier, that is there inside this. Okay, so operational amplifiers and all have been used into this IC integrated circuit. So these two are acting as a switches. Okay, whenever the signal comes out of this operational amplifier and the base of this transistor, activating that particular corresponding motor. That's where, so whenever this is going, suppose say for example, here is a line. For example, here is a line. Okay. So when this is straightly going on, okay, on this line, and it's fine, no problem. It is well balanced with the proper two presets here. So properly balanced, it is going straight. But the moment, whenever due to various reasons, whenever this takes little turn that side, what happens immediately? This sensor will sense the line and it will detect the error, and the error amplifier is going to send correction to the other motor. So that's where the other motor will correct it like this. And little after time, if suppose say the error is taking place in that direction, and the error amplifier will activate this motor. Okay. So this is how they are adjusting themselves. So basically the sense and the output of LDR as a error signal to this operational amplifier IC, and the corrections, comparisons, corrections, and then the signal for corrections are coming to the transistors, and the transistors are taking care of driving the motors. That's where that particular rotation, more conduction, more RPM, okay, more correction, faster. So it is going to correct the problem, the error, as earliest as possible. That's where you might see little shake there and here for correction, but you can improve further more with no shake at all. Such a kind of accurately you can set with the next level of circuitries. Okay, for now, understanding the basic of sensor as error signal to the comparators, and then output of the comparators to the transistors, and then controlling the motors. So up to some extent, okay, this is good, this is cute. Okay, thanks to the designers, make you on concept very clear about this. So this is how you need to tinker, man. Tinkering is all about getting an idea and then ideate and building a prototype. This is a prototype. Okay, so a lot of people makes this, the line following robot. A lot of people all across the world. But the thing is, I wish my mentees will understand the basics of it. Just making is first level, okay? But you need to understand what are the points inside, how the designers thought, what values they kept, the resistors, and what kind of transistors they have used, what kind of IC they have used, how they have designed the circuit board. So all these bare minimum calculations, even then, what is the power consumed by the motor, and what is the power we have in the battery storage, how long these batteries will support once I switch on this. Keep on, suppose if I put a circular, line, then automatically it will be following in a circular path. So at that time, how long it works like, how long it continues moving in the same circle. That's another question. Like that, you all can understand many things, okay? So for now, once again, happy tinkering. Keep tinkering. Let's build, I means, innovative and innovative India. So towards productive India. So I hope learning all these things at school level, hands-on activity, then I'm sure you'll all will become very good entrepreneurs because you'll gain the confidence in making. Okay, that's where whatever new idea comes, and you will make a solution to the new idea. That's where a new ideas, new innovations, new startups, new entrepreneurship. That's where the production. Why import when you can export? So make in India, made in India, skill India, school India. Thank you for watching this, understanding this, and if anyone interested, then I can share the link or the material so that you all can make it. So enjoy making, enjoy tinkering. Okay, all the best, take care, bye-bye. Signing off, your tinkering support, tinkering mentor, regional mentor of change associated with Atal Innovation Mission, Niti Aayog, Government of India. So let's do more tinkering. Let's build productive India from school India. Once again, Happy New Year. But now and then, 2024 onwards, you all have to tinker, you all have to make and export all the products. Not only many as possible. What are all the various products we all can tinker and make? Doesn't matter. It can be a nail cutter also. From very small thing to very big. So let's do machine development. Okay? Let's solve the problems. We, almost 140 crores people of India, are itself a big market for all of you. Whatever you innovate, whatever you make, that's it. It's a big market for you. So, enjoy the business. Enjoy as a maker. So let's participate our Atal Innovation Mission's flagship program, marathons, and also Maker Ferry programs. Okay? All the best. Take care. Bye-bye. Signing off, your Scientific Srinivas, Solar Srinivas, Science Srinivas from scientificstudents.com. Thank you. Bye-bye.